just wanna hold you, girl. But you keep on running to his world. I don't know why you're still with him. He don't care about your existence. Girl, it's time for intermission.
Hi, this is NASA. Today we look at titration calculations. Okay, so what can we do first? The first thing we're going to need is this formula triangle. N over C times V. So that's N is number of moles, C is concentration in moles per decimeters cubed, and V is volume in decimeters cubed. So we're going to need that, and that's the key triangle. That's the only triangle that we're going to need for this. So let's go on. All right, then this is the first question we're going to approach. So if 25 centimeters cubed of a solution of sodium hydroxide is exactly neutralized by 13.5 centimeters cubed of 0.6 moles per decimeters cubed of sulfuric acid, what is the concentration of the alkaline? What do we mean by this? In order to understand this further, I think we need to see a practical demonstration. So let's talk about our titration question. You have a long piece of glassware called a burette. Underneath you've got your conical flask, and the conical flask will contain a certain known volume of a particular solution that you're trying to find the concentration of. Usually it's going to be the alkali inside the conical flask, and you've got your acid in the burette, but sometimes it can be the other way around. In this conical flask, there's also an indicator that you add in with the solution. This indicator is different to universal indicator, which gives graduation color. This indicator allows us to have what is called an end point. It allows us, to the drop, to determine when the substance has been neutralized. And what we'd have in here is a certain volume of, in this case, we'd have sulfuric acid. Sometimes you can have different acids depending upon what your reaction is going to be. But you would take the starting volume, reading from the bottom of the meniscus there, you'll take your starting volume, and then afterwards you would run the tap, and then the moment it changes color, you turn off the tap, and you'll realize that it has now been neutralized. And so what this question is saying is that I have 25 centimeters cubed of sodium hydroxide in this conical flask, and then I have sulfuric acid in this burette. Now I turn on the burette tap, and at exactly 13.5 centimeters cubed, the solution in here neutralized. And we know it neutralized because the indicator changed color. Now I said I have my acid here. This acid is a known concentration of acid. So I have chosen to use 0.6 moles per decimeters cubed of acid. This is my known concentration of sulfuric acid. So that means, once again, it took 13.5 centimeters cubed of this to neutralize this. That's all it's saying. And it's asking us to calculate the concentration of the alkali, knowing that. This is the way you can do it. Okay, so what's this question saying? That means that we had 25 centimeters cubed of the sodium hydroxide solution inside our flask, and 13.5 centimeters cubed of sulfuric acid inside the burette of a known concentration of 0.6 moles per decimeters cubed neutralized that sodium hydroxide. We want to find the concentration of the alkali. The first thing you need to do is to write down a balanced equation. So that's 2NaOH plus H2SO4 gives us Na2SO4 plus 2H2O. Once you've done that, you should draw a table. Underneath the alkali, put alkali. Underneath the acid, put acid. Then afterwards, you're just going to write NCV. NCV. From this, we can see that sulfuric acid is 0.6 moles per decimeters cubed. So I'm going to write just the number 0.6. Okay, volume is going to be in decimeters cubed. So when we have a look at the acid, neutralized by exactly 13.5, we're going to turn that into decimeters cubed. So we've got 0.0135. On the alkali situation, we only have volume, so that will be 0.025. Now, from this equation, we can calculate the number of moles of the acid. So, cover up N, number of moles, and we have concentration times volume. Okay, so we need to multiply these. 0.6 times 0.0135 gives us 0.0081. Then we need to look at the number of moles in terms of the mole ratio. So, if you have watched my previous video on finding the mass of a substance using the number of moles, what I would suggest you have a look at that if you haven't. What you will find here is this is a 2-to-1 ratio, because 2 moles of sodium hydroxide are required to react with 1 mole of sulfuric acid for this reaction to take place. So I multiply this figure by 2, and it gives me 0.0162. From this, we can now calculate the concentration using this very same triangle, cover up concentration, and its number of moles divided by volume. So we take 0.0162 divided by 0.025, and we come out with a concentration of 0.648. Now, because we can only be accurate to 2 significant figures, because we were only given lists of 2 significant figures, we can only have our answer accurate to 2 significant figures. This means we must round it to 0.65, and then put in our units, moles, decimeters cubed. And that's our answer. Now for one more example, and you can try this. So it says 10 centimeters cubed of a solution of potassium hydroxide was titrated with a 0.10 molar solution of hydrochloric acid. 13.5 centimeters cubed of the acid was required for neutralization. Calculate the concentration of the potassium hydroxide solution. Okay, so the first thing you need to understand is whenever you see this, that means molar. It's a capital M. don't get it confused with units of moles. It's not the same. And in fact, it's the old way of saying moles per decimeters cubed. So it's concentrations, unit of concentration. It's the old way of saying that. That is what your old teachers will say. So you see it in old books, the old professors, anyone from the real previous generations, they're going to use that. But this is what we're talking about right here. Same approach afterwards, same approach. Have we go at this by drawing the table? Okay, so let's begin. Potassium hydroxide, hydrochloric acid. So potassium hydroxide is KOH, and hydrochloric acid plus HCl gives us KCl plus H2. That is an alkali plus an acid gives us a salt plus water. It's a neutralization reaction. It's balanced. Okay, so I'll draw my table. Our formula triangle. Once again, NCV, NCV. What can we pick out from this? Our solution of potassium hydroxide was 10 centimeters cubed. We need to convert that into decimeters cubed first. So divide that by 1,000. That's going to be 0.001. And our volume of acid, which is 13.5, so we're going to have that as 0.0135 in decimeters cubed, and our concentration of the acid, which we are told is 0.10, and now we can calculate our number of moles of the acid because we don't have anything else. So, calculate the number of moles of acid, so that is 0.10 multiplied by 0.0135 gives us 0.00135. And having a look at this, the ratio in here is 1 mole of hydrochloric acid is required to react with 1 mole of potassium hydroxide for this reaction to go through. So from this, I know that this must also be 0.00135, and I can calculate the concentration by covering this up in my formula triangle and doing number of moles divided by volume. Number of moles divided by volume is 0.135. And now, once again, I can only get this to 2 significant figures. So I must round this to 0.14 moles per dm because we only have our answer there to 2 significant figures, so we can only be accurate to 2 significant figures. And that is that. So I hope that helped, and keep rocking. The more observant of you will have noticed something. I'm wearing entirely different clothes. And this is not because I have superpowers. This is because the last time I recorded this was on a Friday. And I spent half an hour recording the video and found out that it didn't actually record. I'm a bit of a resilient person. At the same time, I did it for you. You better make the most out of this video. So like, subscribe, hit the bell, and share.
And I just wanna hold you, girl. But you keep on running to his world. I don't know why you're still with him. He don't care about your existence. Girl, it's time for intermission. You don't know what you've been missing. I could see your beauty within, even though it's your decision.